So let's do this particular physics questions. So I'm going to start from number 7. I'm going to end in number 9. Now the first question says from number 7 here. It says a body undergoes a uniform accelerated motion and it has 2 points. The first point is it started at the first seconds and the velocity at that time was 10 meters per second, and 20 seconds the velocity at that time was 48 meters per second on the velocity time graph. The acceleration of the body is, so we are supposed to look for acceleration. Now before solving any physics question, the first thing you want to do is you write out your parameters. What are the things that are given to you? Now from this question I can tell you that I was given the initial velocity to be 10 meters per second and the final velocity to be 48 meters per second. So the time was from 1 second to 20 seconds. That makes it 19 seconds because it didn't start at 0. It started at 1. So from 1 to 19, from 1 to 20 is actually 19. So let's try to solve this question. So question number 7. So what we were given? We were given our initial velocity to be 10 meters per second, our final velocity to be 48, and our time for the motion, like I said, is 19 seconds. So what is the acceleration? To solve any question that is related to motion, the thing we do is that you have to write down the equation of motion and you use the one that is significant, the one that is suitable for the questions you are trying to solve. So what are the equation of motions? So these are the 3 equation of motions that are majorly that will solve 90% of your question related to motion. The first one is v equals to u plus at. The second one is v square equals to u square plus 2as. And the third one is s equals ut plus half at squared. So with these 3 formulas, you can solve any question on physics, on motion, and you solve it not foolishly. You will solve it wisely, not foolishly though. So you'll be able to solve the question. The answer, the question will look like a fool by the time you finish solving them. So looking at this now, we are given u, we have v, and we have t. So we are looking for a. If you look at this, the formula that contains everything that we need is this first formula: v, u, a, and t. V, u, a, t. So this one has this. The other ones, they are not suitable enough. So let's just use the formula that will solve them. So our v was given. So v equals to u plus 80. That's the formula we'll be using. So our v was given as 48. Our u is 10. So substituting that in the equation, you have 48 equals to a times 19, which is the time. So you have 48 equals to 19a. So from there, collecting like times and bringing 10 to come and meet 48. Then you have 48 minus 10 equals to 19a. Then we can say that 19 equals to 38. From I just rearrange this. This is normal math. Everybody that is in at least in SS1 and you've been solving maths from GSS1 should be able to at least manipulate their way around this area. So 19 equals to 38. Dividing both sides by 19, our A is 2 meters per second squared. So we solve this question. You see how foolish the question could be. Very simple. It's just a matter of knowing the formula, bringing out the parameters of your question, and solving it. End of story. Second question is more like it says a motorist traveling at 72 kilometers per hour on sighting a stop road sign applies the brake such that under constant deceleration the car is brought to a stop within a distance of 50 meters. The magnitude of deceleration is, we know. Physics people, they like to give some useless stories that nobody cares about. You know what the thing is that let us just bring out the parameters from the question and then we solve it with the formulas that they gave us. All these stories, I don't think anybody cares about the story, and it's more of it tends to kind of confuse you if you dwell too much on the story. What you should be doing is let us bring out our parameters from the question. So the first thing is we know that a car was moving and it was traveling at 72 kilometers per hour. Okay, so because they gave the only thing that is there is that the question was given in kilometer per hour and we are supposed to get our answer in meters per second squared. So we have to convert this 72 kilometers to meters per second. Okay, then they said the guy applied a brake. So if he applies a brake, that means this velocity given is initial velocity. Our final velocity is 0 because the guy is going to stop. So the distance given is 50. So that is all the parameters here. Our velocity, initial velocity is 72 kilometers per hour. Our final velocity is 0 because it's coming to a rest. and the distance covered is 50 meters per second. So let's try to solve that. Question number 8. So let's write down our parameters. So since we are giving this one in 72 kilometers per hour, what we are going to do is we are going to convert it to meters per second. So, and kilo means 1000. Okay, so we kilometer, so 1072 times 1000 meter divided by hour. So if I convert hour to minutes, 1 hour is 60 minutes. That means, and if I want to convert minutes to seconds, that means 60 times 60. So we say 72 times 1000 divided by 60 times 60, because 60 for the first minute and then the second 60 for seconds. So if you do this using your calculator, you should get our initial velocity to be 20 meters per second from the question. Our final velocity is 0, since they said the the car came to rest, like it was decelerated. So that's that. Then the let me remove this one. Then what else was we given? We were given our distance. The distance to come to rest is 50 meters per second. So once we have written these parameters down, the only thing they're asking for is deceleration. Now, deceleration and acceleration, they are basically the same thing. The only thing that you use to differentiate between them, what you used to know the difference, is the negative sign. When you say a negative sign, by the time you calculate, that means that it is deceleration. So we are still using the same formula. And what are the formulas that we have? Our formula is v equals to u plus at, v square equals to u square plus 2a, s equals to ut plus v2. So if you look at this, all the parameters we are given, which one suits this? You have u, you have v, you have x, you have a. So the second formula actually does justice to this. And the second formula is v square equals to u square plus 2as. So substitute your values and the answer will jump to you like a fool. So let's do that. So 0 square equals to 20 square plus 2 times a. Since we are looking for the deceleration, which is same thing as the acceleration. So 0 square equals to, so from there, 20 squared is 400. 2 times a, 2a times 50. That is 100a. So if you take this one to the other side, it becomes negative. So 0 minus 400 equals to 100a. So 100 equals to minus 400. So dividing both sides by 100, our a is 4 meters per second square. Please, don't mind me. I did not put the unit. Please always put unit. I think physics will always deduct your mark for not putting the unit. So our unit is meter per second square. So we do that and we are done with question number 8. Now let's go to question number 9. Okay. Now the ninth question is a bit complicated than the others. It says two bodies X and Y start from rest. When they say start from rest, that means our initial velocity is 0. That is the parameters we are getting. Like I said, don't I don't want to swear that I don't it doesn't matter. It does not matter what the story they are saying. Don't give too much thought into their stories. Okay, don't be too focused on their stories. Just bring out the parameters that is given. Okay, so they said we have two bodies X and Y, and both bodies start from rest and move with the uniform acceleration of a and 4a respectively. So X moves with a, Y moves with 4a. That is the acceleration given. If the bodies cover the same distance, that means the distance covered by both bodies is, let's call it whatever, they are going to cover the same distance. This in time ts and ty, then the ratio of ts to ty is what? So what they ask us to do is we should find the ratio of ts to ty given the parameters. Now, what are the parameters? Again, let me say it for the third time. So x starting from rest, that means initial velocity is 0. The acceleration of x is a, okay? And the distance covered, they didn't give us, but we know that it's the same distance covered by y. So don't let me talk too much. Let me just go into solving the question. Okay, so now let's look at this. The body x, so the acceleration is given as a. The initial velocity, since they said it started from rest, is 0. The t is tx. They said the time is tx. That's what they said. And the distance covered is s. I just use s to represent it. You can use anything else, but since they didn't give us, but let's just use s to make more sense with respect to the formula that we use. So for body y, the acceleration is 4a. The initial velocity is 0. The time for y is ty, and the distance covered is also s, since they both cover the same distance. Now, the question says, let's go to the question. the ratio of ts to ty. So the time of x and time of y. So the x, what we are going to calculate is the time of x and the time of y. That's all. And then we find the ratio. If you can list out the parameters, find the time of s, find the time of y, you're good to go. So let's do that. So let's look at the formula that sorts this question, because we have a, u, t, and x and distance. So let's look at it. So which one solve this? V equals to u plus at will not solve that because there is no distance in that one. So if I was to use v square equals to u square plus 2as, it wouldn't work because there is no time in this second equation. But this third one has distance, it has initial velocity in it, and it has time and acceleration. So this is the best formula that will solve this particular equation. So let's solve it. So with body s, let's start from body s and use this formula, s equals to ut plus half at squared to solve it. For body x. So for body x, the initial velocity is 0. We put 0. The time is tx, it is here, plus half times the acceleration is a, times the time is ts squared. So you have t underscore x, call it anything you want, just tx. So we can say that from there, 0 times ts, that will give us 0. This will be 1 times a times ts squared, everything over 2. So this will be ats squared, everything over 2. So from there we can say that s equals to ats squared over 2. Since 0 is insignificant, we throw it away. So the next thing is you just cross multiply. This is just basic math. Okay, so for you to be able to do physics efficiently, your math too must be up there. So from there you cross multiply. If you cross multiply, 2x equals to at squared x. So don't forget, we are looking for the time of x. So your goal in life, your goal to solve this question is that to make sure that ts stand alone. All right. So from there we can say that divide both side by a, tx. So this 2x over a equals to ts squared. So I have isolated ts squared, but don't forget I'm supposed to find tx, not ts squared. So in order to find tx, since ts is carrying square, you do the opposite. So you find the square root of both sides. If you find the square root of both sides, we discover that our ts is 2x over a. That doesn't mean we have solved the question. Some people is already like, yeah, we solved it. No, we didn't solve the question. We only find tx. So we are going to do the same thing for ty. All right. So let's do the same thing for ty. Let me move my fine face away from here, or let me just put it somewhere here. All right. So to find ty, we are going to go through the same thing. Okay. Okay. I can't be here. All right. Let me be here. We have to go through the same thing. And how do we go through the same thing? Use the same formula, s equals to ut plus half at squared, and that's what we're going to do. S equals to ut plus half at squared. Yes, we've done that. Then we substitute the values. So initial velocity for y is t0. The acceleration for y is 4a. The t is ty, and distance is x. So that's what we substituted here. So initial velocity is 0 times ty plus 1 over 2 times the acceleration for this guy is 4a times ty squared. So from there we can say that 0, because anything multiplied by 0 gives 0, plus 4a times ty squared over 2. So from there you can say that this is s equals to 4a ty squared over 2. So we can go ahead and do some kind of division, since 2 can divide 4. So we can say 2 here, 1, 2 here. That would give us 2a ty squared. So I think that must be the next thing I did. So s equals to 2a ty squared. But don't forget, we are trying to find ty. So in order to find ty, you have to isolate ty to stand alone by dividing both sides by 2a. So if you divide both sides by 2a, you get ty squared will be x over 2a. So since ty squared equals to x over 2a, find the square root of both sides. If you find the square root of both sides, ty will be equals to s over 2a. So from this question now, I was able to find tx, which is this guy here, and I was able to find ty, which is this guy here. So once I'm done that, the question actually said for me that I should find, where is it, the ratio of tx to ty. That's what the question asks us to do. Find the ratio of tx to ty. And that's what I'm going to try to do now to find the ratio of TS to TY. Since I've already gotten the value for TS and I've gotten the value for TY, what I'm going to do is I'm just going to let's see what. So I'm going to just find TS ratio TY. Let me come here back. So so like I said, I've done this. So Tx is 2x square root of 2x over a. Ty is square root of x over 2a. So Tx ratio Ty. How do we now do it? So you find just that is Ts ratio Ty. Ratio is more like division. When you say two something ratio, something is division. So since both of them are under, they are both square roots, you can just put them under a single square root and you solve it. I say that 2x over a divided by x over 2a, because this is representing Tx, this is representing Ty. Again, procedural math, just solve from there. So that means that you change this division to multiplication. If you change division to multiplication, there's going to be a reciprocal. 2a will go up, x will come down. So 2x over a will be, so you do that. So from there, a can cancel out a, or better still, just say multiply. This is 4as over as. So from there, as cancel out as. So you have square root of 4 over 1. So that will be square root of 4 over 1 will be 2 over 1. So 2 over 1 is same thing as what? 2 ratio 1. Now I've come to the end of these particular questions. Now these questions are not difficult if you do not practice them. Okay? But if you practice the, what did I say? I just these questions are not difficult only if you practice them. I think that's what I should have said. All right, because if you look at this now, what I did now, I actually am the one that solved this question. You did nothing. You are just staring at the screen. That's what you did. So in order to know that maybe whether you know it, I'm going to drop the question in the description. I'll take a snapshot of the question. I'll put it in this description. Get the question, pause the video, try to solve it by yourself. If you don't get it, watch the video again, maybe see where you are wrong. But better still, make sure that you solve the question by yourself. And at the end of the day, please subscribe to my channel, and God will bless you. Thank you.